sklearn, utils, sparsfinx fast and place cs row normalizer 1. Description. This function normalizes the rows of a CSR matrix in place using the L1 norm. This means that for each row, the values are divided by the sum of their absolute values. This results in each row having a unit L1 norm sum of absolute values equals 1. Inputs. X a CSR matrix representing the input data. Copy a Boolean value indicating whether to copy the input matrix before normalization. If true, a copy is created and modified, leaving the original matrix untouched. If false, the normalization is performed in place on the original matrix. Outputs. X the CSR matrix with normalized rows. If copy is true, this is a modified copy of the original matrix. If copy is false, this is the original matrix, modified in place. Steps. Calculate the sum of absolute values for each row in the input CSR matrix. Divide each element in the matrix by the corresponding row sum. Metrics. L1 norm. This can be used to verify that all rows have a unit L1 norm after normalization. Visualization plots. Heat map. A heat map of the normalized matrix can be visualized to show the distribution of values across rows and columns. Fine-tune parameters. Copy. This parameter allows you to control whether the normalization is performed in place on the original matrix or on a copy. Setting copy to true ensures that the original matrix remains untouched. Uncertainty methods. None. This function does not involve any uncertainty estimation. Challenges and fixes. Challenge 1 0 row sum. If a row in the input matrix has all zeros, dividing by its row sum will result in division by 0, leading to an error. Sample use case that resulted in challenge 1 a matrix with a row containing only zeros. Fixes to challenge 1. Handle 0 row sums by skipping normalization for those rows. Set the normalized values to 0 for rows with all zeros. Challenge 2 numerical instability in extreme cases. The sum of absolute values for a row might be very large or very small, leading to numerical instability during the normalization process. Sample use case that resulted in challenge 2 a matrix with very large or very small values. Fixes to challenge 2. Use robust numerical algorithms to avoid numerical instability. Scale the values before normalization to reduce the potential for large or small row sums.